Hello everyone. In this video, I'll teach you chapter 4 motion in a plane. So in motion in a plane, some basic things are required. So in starting, I'll try to boost your concept on vectors. Vectors. So in previous classes we have already studied about what is a scalar quantity and what is vector quantity. So already we saw that those physical quantities which have magnitude but no particular direction is called a scalar. But those physical quantities which have both magnitude and direction are called vector quantity. For example, velocity is a vector quantity, force is a vector quantity, displacement is a vector quantity, distance, mass, work done, these all parameters are a scalar quantity. I hope it is clear to you all. Now, you see, when an object moves on a straight line, So suppose this is the origin, and from origin it is moving toward positive x-axis. So suppose it moved how much? It moved x distance along x-axis. And if it moves on the left side of this origin, so suppose it will be minus x, because on this this side x prime axis, it is minus sign is given. This minus sign is given. So if you want to represent any parameter, on this axis, on x-axis. So suppose one parameter I am representing displacement. So displacement in this direction will be equal to what? X. So it is going in the positive x-axis. But if I put here one minus x, so it will indicate the direction. So if a body is moving on a straight line, then direction is not a major matter of concern, because we know the direction. Either it is moving on the positive x-axis or it is moving on the negative x-axis. If it is on the positive x-axis, then x, and if it is moving on the negative x-axis, just put a minus sign. So direction is not the matter of concern here. So here, yes, displacement will be a vector quantity, because we know how much distance we have moved and which direction we are moving. We are moving along positive x-axis. But as soon as you put minus sign, you are moving along negative x-axis. Okay, direction is also known, how much distance you have moved, how much displacement you have covered. That also known to us. So that means when we talk about motion of a body or object on one axis, then the direction is not a major concern. But what we can say, when a body is moving in a plane or in a space, if a body moves on a plane or in a space, so suppose a body is moving on a Cartesian plane. The Cartesian plane is on a x-axis, x prime, y prime. So if the object is moving in this direction. Now what can you say about the direction? So in this case, it is very difficult to identify in which direction the object is moving. Okay, but what can you say about, again, in three dimensions? Suppose in a room a vector is oriented. Suppose initially an object is here and it reached here. So yes, we can calculate what is the distance in both 2 dimensions and 3 dimensions. But what will be the direction? In which direction the object is moving? It is very difficult to identify. So that is why one new concept is added. Okay, that is study of vector. So let us see a little bit some definition and little bit more concept in details about vectors. So normally, representation of vector, we are studying how the vector is represented. A vector is represented by a arrow. So in this arrow, this is called tail, and this is called head. And the direction of the vector is from tail to head. Direction of this vector is from tail to head. Okay. Now let us see some different types of vectors. So number one, let us see position vector. Now suppose we take a Cartesian plane. Now this Cartesian plane, one point is lying here. One point is lying point, that this point is lambda p. So what is the distance of this point? What is the distance of this point from the origin? Suppose this OP is the distance. Now suppose a object moves on this path OP. The object moves on this path OP. So we know that object is moving in a object has some distance or having some displacement is discovered. But in which direction it is moving? Okay, to certify this kind of problem, we have introduced the position of what? Definition of vector or concept of vector. Now, so OP or OP you put a arrow mark. So this OP will indicate this OP and when arrow mark is given on it, it indicates a vector. Means the object is moving from O to P. The direction is along O to P. The distance covered, but direction is from O to P. So what does the P indicate? P is the point where this point is lying. Where this point is lying? Can I say this point is 1 lakh kilometer from the from the America? So yes, this can be true. Because if I keep a point 1 lakh kilometer away from America, then obviously this distance will be 1 lakh. But the position of the point we want to certify here. The position of the point we want to certify with respect to what? So here with respect to origin of the Cartesian plane. So OP vector will indicate nothing but if I write OP vector, what does it indicate? Simply it indicates the position of the point P with respect to what? Origin. Position of the point P with respect to origin. So what you can say, what kind of vector OP vector is? It's a position vector. It's a position vector. So let us see another vector that is called displacement vector. Displacement vector. Now let us again consider a Cartesian plane. Cartesian plane x-axis and this is y-axis. Along this it will be x prime, along this it will be y prime. So if I take a point here, suppose the point name is P and this point has some distance from the origin. So what this OP vector will be called? OP vector will be called position vector. Position vector. Why it is called position vector? Because it tells us the position of the point P from the origin. Position of the point P with respect to origin, that is why it is called position vector. Already I told you. Now let's consider another point. Suppose this point is Q. What is the distance of this point from the origin? That is O2. What do we say about O2? O2 will also be a position vector. What kind of vector it is? Position vector. Why position vector? Because it will get the position of the point Q with respect to origin. Position of the point Q with respect to origin. But when I join this line, then whether this PQ is a position vector? Answer is no. Because when we say position vector, that means it will get the distance of the point from the origin. Because OP vector is given, like here, OP vector. So OP vector if it is given, that means the distance of the point P from the origin we have considered. And the direction is along O. Direction is from O to P. But here, is it from origin? What is PQ vector? First of all, we should know. PQ vector is called displacement vector. PQ vector is called displacement vector. It is called displacement vector. Because PQ indicate what? Displacement of an object from the point P to Q when viewed from origin. When viewed from origin, or also we can say with respect to origin. So PQ vector indicate what? Displacement vector from point P to Q. Or also we can say the position of an object from P to Q. At a particular time, object was at P. After some time, it reached Q. When it is viewed from O, you see that there is a displacement from P to Q. So that is why this PQ is called displacement vector. displacement vector. Now let us see some more type of vectors. Equal vectors. Equal vectors. What is the meaning of equal vectors? Two vectors. What is this? Another one is this. This is A vector and this one is B vector. So two vectors said to be equal. Two vectors are equal. Two vectors are said to be equal vectors. Equal vectors. If their magnitude are same, if their magnitude are same and have same orientation. Same orientation means same direction. So what you can conclude? You can conclude that two vectors are said to be equal if they are equal in magnitude and also they are going in the same direction. If they are equal in magnitude and going in the same direction, we can say that these two vectors are nothing but equal vectors. Now, let us see negative of vector. Negative of a vector. So what is negative of vector? Suppose one vector is going in this direction. A vector. So if I multiply here on this vector A, if I multiply on this vector minus sign, its direction will get changed. Already I told you when you put minus sign on the x-axis, it will turn into the negative x-axis. Similarly here also, it will turn into. But whether these two vectors are same, answer is no. Why? Because although they are equal in magnitude, but their directions are not same. And since their directions are not same, they are not equal vectors. That is why this vector can be represented by another name, that is called B vector. B vector equal to minus of A. So A vector, although they are equal, A vector and this B vector, although they are equal in magnitude, but they are not same in direction. That is why these two are not equal vectors, but B vector is called negative of A vector. B vector is called negative of A vector. I hope you have understood this. Next is modulus of a vector. Modulus of a vector. Modulus of a vector. So suppose one vector is there. So when I write vector, it will represent both magnitude and direction. It has both magnitude and direction. We are concerned about both magnitude and direction. But when I write mode of a vector, modulus of a vector. So modulus of a vector is represented by a vector with their modulus. This is also equal to a. So when I write this, we are concerned only about the magnitude. Direction where it is going, it doesn't matter to us. So we are only dealing with magnitude part. So modulus of a vector means what? Modulus of a vector means what? It is only magnitude part of a vector. Direction we are not concerned with. Okay. Okay. Next is unit vector. Unit vector. This is very important. Unit vector. Unit vector. What is unit vector? Remember very specifically. Those vectors whose magnitude is equal to 1 is called unit vector. Always remember this. Those vectors whose magnitude is 1 is called unit vector. Now, why we need unit vector? This is very important. Question arises in your mind, right? So, what is the function of this unit vector? Why unit vector is required? So, the function of unit vector is to indicate direction. What is unit vector? Any vector whose magnitude is 1 is called unit vector, and the function of the unit vector is to indicate direction. The function of unit vector is to indicate direction. Every physical quantity has its own unit vector. Every physical quantity has its own unit vector. Now let us suppose a vector. So any vector can be represented both in magnitude as well as in direction. So this vector we have to express in terms of magnitude and direction. So magnitude part we will write first. A vector, if I put modulus, it will give us magnitude. Modulus means magnitude. something will be there, no, something will be there which will indicate the direction of a vector. That something is nothing but a cap. So this a cap is called unit vector. So how you know it is a unit vector? Because this cap is present. This cap will indicate that it's a unit vector. This cap will indicate that this a cap is a unit vector. Any parameter like force also can be present. This is magnitude and this is what? Direction. Remember that. Whenever you calculate force, velocity, always you have to say magnitude you have to calculate, but also you have to indicate direction always. You have to always indicate direction. Now, if a vector is equal to m modulus a cap, so it will be a cap. A cap will be equal to a vector divided by a vector modulus. We will see this one a bit later on also. Okay. Now, there are three types of unit vectors. Three main unit vectors we can say, or three very what is called branded unit vectors. So what are those? Number one is I cap. I cap is a unit vector. So what is the function of it? Whose direction it indicates? So it indicates direction of x-axis. Direction of x-axis. Another is the j cap. It indicates direction of y-axis. And another is the x cap. It indicates direction of z-axis. Direction of z. I hope it is clear to you. Now, let us see multiplication of a vector by a scalar by a real number. Multiplication of a vector by a real number. Now, suppose the vector is present here. What is that vector? A vector. Suppose I multiply this vector by 2. So what will happen? You see, this is the length of this vector. If you multiply by 2, what will happen? What will happen? The magnitude part only will change. You will see the direction. If the direction is changing, answer is no. Because this vector is moving in this direction and parallel to this vector is moving. So what happened? The length of the vector got changed. That means what? When you multiply any vector by any real number or by any scalar, only the magnitude part will get changed, but the direction will not get affected. So a vector is equal to twice of e vector. So if I multiply here 3, then direction will become 3a. If you multiply positive real number, but obviously if you multiply a negative real number, then obviously if this is a vector, the negative real number if you multiply, then it will obviously direction will get changed. So this is the multiplication of a vector by a real number. So remember always that when you multiply any vector by a real number, the magnitude get affected, but the directions remain same. If you multiply negative, then only direction will get altered. Otherwise, for a positive real number, direction remains same. Okay. Next is co-initial and coterminous. Co-initial and coterminous vectors. So what is the meaning of co-initial vector? If two vectors start from the same point. You see, you can start it from the same point. Then they are called starting point is this, and a vector, b vector originated from this point O. That is why they are called co means same. Initial means a starting point. Co-initial vector. Another, if you take this vector, another vector is this, then this ended at the same point, that is why it is called coterminous vector ended at the same point. That is why it is called coterminous vector. So in this video only this much. In the next video very soon I am going to give you addition of vector. This addition of vector and the multiplication of vectors are really important and very interesting. Till that, goodbye, and we'll see you very soon in the next video. Thank you very much.